What is up, YouTube? Let's learn the process through which OpenID and SAML provide authentication, which is verifying who the user is, and authorization, which is what the user has access to. So let's get into it. So to introduce this, picture the following situation. So a person who wants to watch a movie buys a ticket for it. The movie ticket will allow entry to its holder, but it won't contain any information about the said holder except for the movie that they're authorized to watch. So anyone can use this ticket, right? Even if they weren't the rightful owner, because there's no way of verifying who the holder's identity is. And in this example, we assume OAuth 2.0 functions like a movie ticket. It only provides authorization and it needs further security methods to implement sufficient authentication. So to tackle this vulnerability, this lesson details the following authentication and authorization frameworks. So firstly, we have OpenID Connect. It's an authentication framework that typically works alongside OAuth 2.0. It's an open standard and it enables its users to log in into multiple applications or websites with a singular set of credentials, removing the need to keep different information for various sites. It allows user authentication without needing applications or websites to store user data. And then we have security assertion markup language. It's also an open standard and it's typically deployed in enterprises. It's both an authentication and authorization standard that allows users to access numerous applications using a singular set of credentials. Through SAML, entities can both authenticate and authorize information access from different domains in a secure way. Let's begin by expanding on OpenID Connect. Note that OpenID Connect largely performs the same operations as OpenID, but does it in a more API-friendly manner, so therefore in our context we'll focus more on OpenID Connect. So OpenID Connect typically works alongside the OAuth 2.0 framework, and it provides an authentication layer that sits on top of the OAuth 2.0 protocol. It enables applications to verify the identity of the end users by obtaining their basic profile information through the use of ID tokens. And ID tokens contain a number of attributes or claims about the end user along with information on how they were authenticated. Authorization servers provide ID tokens to the requesting application. These tokens contain information about the end user's identity. They're encoded as JWTs and follow a similar template to the access token in its payload. So below you can see information like the user, who's requesting the token, other information about the user like their name, gender, things like that. So this process follows the same flow as OAuth 2.0 mentioned in an earlier lesson, but along with the access token, an ID token is also provided. The users can access multiple applications using the same ID token, which is known as SSOs. The application then uses the access token and the ID token to make requests for data in the resource server. So here we have an application in our picture, and they get an access token and an ID token from our authorization server. And single sign-on refers to the authentication scheme through which users log in with a singular set of credentials to several different applications. It ensures that the user only has to authenticate once, after which they can access numerous related applications without the need to authenticate separately into them. So what is the difference between access tokens and ID tokens? The purpose of access tokens is to be utilized in OAuth for the purpose of making requests for an API's resources. On the other hand, ID tokens are used in OpenID Connect, which proves the client has been authenticated. Although this is not a requirement of ID tokens, they also contain information about the client's credentials, which access tokens do not. So this framework makes authentication seamless for developers across websites and applications without having to manage their passwords, which can lead to security concerns. When OAuth 2.0 is utilized with OpenID Connect, it enhances the overall security and reliability of the process while also enabling SSO functionality. This eliminates the need for frequent transmission of sensitive user credentials, thereby mitigating the risk of several types of attacks. Note that OpenID Connect differs from OAuth 2.0 in that the latter is used to protect user resources, whereas the former is used to produce secure sign-in experiences by authenticating who the user is. So let's talk about OpenID Connect's advantages and disadvantages. So the advantages are that single sign-on streamlines logging into a variety of applications, and it can be used in both mobile and desktop applications. But the disadvantages are it doesn't authorize on its own, it functions on top of OAuth 2.0, and it's considered less secure than its alternatives because it's susceptible to phishing attacks. It doesn't have global integration to the extent of OAuth and SAML. So, Security Assertion Markup Language, or SAML for short, allows users to access multiple applications with a singular login by using SSOs. It has both authentication and authorization capabilities in its process of exchanging user data between entities. Its updated version, SAML 2.0, was released in 2005, and it's built on top of the XML format and is widely used in government and enterprise applications. SAML centralizes authentication and authorization to increase security by eliminating the need to store passwords on the application server. SAML introduces an identity provider, or an IDP, which serves as a trusted entity between a client and a service provider. So the SAML 2.0 process can be condensed into the following steps. So firstly, the application or the service provider the client wishes to access has a trust relationship with the IDP or the identity provider. And then a client wishes to access a service provider. And then since it isn't authenticated, it's sent to do so in the identity provider. And it most commonly authenticates itself by signing in with its credentials. So once it's authenticated, the IDP generates a SAML assertion. A SAML assertion is a generated XML document that the IDP forwards to applications it has a trust relationship with. And the SAML assertion is sent to the client, and then the client forwards the SAML assertion to the service provider. The service provider receives the SAML assertion and maps it to its own user storage using a defined user identifier, such as an email address. And then, since there is a trust relationship between the service provider and the IDP, the client is allowed to access the application, and the same SAML assertion can be forwarded to several service providers that the IDP has a trust relationship with, allowing the client to access multiple applications. And Google implements SAML 2.0 to implement its own single sign-on between its individual applications or resources for both authentication and authorization purposes. It reduces the need for repeated sign-ins, which is particularly useful for an entity such as Google with many applications. So, how is the trust relationship established between the IDP and the service provider? The service provider and the IDP both possess an XML file that contains the metadata and certificates of the entities. They exchange these metadata files to make certain both sides are configured the same way, which ensures that the server is able to map the users to its own database. The metadata also holds certificates and public keys for the entities, which are utilized to increase the security of the data transfer between the IDP and the service provider, and this exchange of metadata establishes trust between the entities. So, the use of SAML 2.0 increases security by eliminating the transmission of additional credentials. This reduces the chances of identity theft, phishing, and spoofing. SAML also increases the speed of application access because the user doesn't have to type in their details to log in, which in turn reduces administration costs to store credentials in the server. To its detriment, SAML isn't designed for modern application types such as SPAs and modern applications, so consumers tend to lean towards other frameworks such as OAuth 2.0 and OpenID Connect for these purposes. Implementing SAML in SPAs and mobile applications is possible, but will lead to security gaps that'll be difficult to overcome. It's also considered more complex when compared to OAuth 2.0 because its process is more complicated to implement and the size of the exchanged assertions is significant due to XML's inherent complexity. Another drawback of SAML is that it's vulnerable to man-in-the-middle attacks because an attacker can intercept the SAML assertion and pretend to be the legitimate user. And SAML is mostly used in large enterprises to implement single sign-ons. In business-to-business and business-to-employee applications, OAuth and OpenID Connect are gaining popularity in recent years, especially in business-to-consumer applications, but SAML is still relevant 2 decades after its inception. So let's do a quick framework comparison. OAuth 2.0, the advantages are it eliminates the weaknesses of password authentication and it allows access to resources for a limited time. It can be used in both mobile and desktop applications. It is widespread in the API landscape and it's easy to implement, but the disadvantages are it doesn't authenticate on its own, but it also uses JSON as its format. And OpenID Connect, the advantages are it uses single sign-on to streamline logging in to a variety of applications, and it can be used for both mobile and desktop applications, but it doesn't authorize on its own, and it needs OAuth 2.0 to do this. And it's considered less secure than its alternatives because of phishing attacks, and it doesn't have global integration to the extent of OAuth and SAML, and it also uses JSON. But SAML employs single sign-on for multiple logins, and it's more practical for enterprises, but it's not designed for SPAs or mobile applications, and the increased complexity when compared to other frameworks. But it also uses XML, which is different than the rest. So, to summarize all this, in this lesson, we examined two protocols, one that functions on top of OpenID Connect to provide both authentication and authorization, whereas the other provides both on its own. Both are valid options when it comes to API design, and their advantages and disadvantages must be compared when debating which framework to implement in our system. If our API communicates with SPAs and mobile applications, OpenID Connect with OAuth is the best way to implement both authentication and authorization. OpenID Connect isn't as widely supported as SAML, and we may prefer the latter in those cases where this becomes an issue. So let's do a quick quiz. SAML functions on top of the OpenID Connect framework. The answer to this is false because we know that SAML is an all-in-one solution that provides authentication and authorization, and it uses XML and it's used for enterprises, whereas OpenID Connect sits on top of OAuth 2.0 to provide these same functionalities. And SSOs can increase the security of our system. The answer to this is true because using SSOs we can reduce the number of user credentials that are being transmitted, which prevent a lot of different attacks. Thanks so much for watching. This is a topic that I was really curious about, and I had fun learning. I'm learning this basically a week ahead of you guys and then presenting this information, so I don't know everything, and if you have any questions you can leave a comment and I'll get back to you. And this isn't just a tech YouTube channel. I really want to do self-improvement content, fitness content eventually, and hopefully you can stick around for that. So leave a like and subscribe, and I'll see you in the next one. Y'all have a good rest of your week.